Welcome to Lesson 2, Week 1 of SENV102. In this lesson we'll be learning about simple maps, just what they are and stuff like that, and what we can do with them. First of all, a map, as we know it, can be one of many things. First of all, we can talk about, in biology, we talk about gene maps. They're indications of where individual genes are located on chromosomes. We're not going to be dealing with that. Maps can also represent thoughts, ideas, concepts, like these mind maps. We're not going to be dealing with them either. Here's an interesting example. This is a map of the US showing the location of the McDonald's stores. I think the different colors represent the number of Big Macs they sell. The brighter it is, the more Big Macs. I think, or I guess, I don't know. I never looked it up. These maps here show the political boundaries in the US, indicating our moral fiber, or the moral fiber of the residents there. I think red being the baddest, blue being the not so bad. I suggest this is a good thing this is a map of the US, not a map of Canada. It might be an interesting little study. This last map is a 3D contour map showing just outlines that can be done quite easily on a home computer. You can turn any topographical map into this sort of thing with a little bit of money. It's not too difficult, and if you've got time to spend the time, take a look at it. But we won't be dealing with that in this course. This is an image of a cuneiform tablet. Cuneiform tablets are made out of clay, baked in clay, and they have scratched in them directions. In this case, they think this tablet is 5,000 years old, so it represents perhaps the oldest known map. It represents the city of Nippur. It's located somewhere in Samaria. I guess the Sumerians made maps like this to help strangers move around their town. Unfortunately, the Sumerians didn't have access to Google Maps for their tablets. All maps are an attempt to show where we are in our world, big world or little world, and to show where we can go and how to get there. That's the goal of a map. One of the things that can happen is, of course, when you're reading the map, you can run into problems. One of my favorite expressions I use with my wife when she accuses me of being lost. I tell her, I'm not lost, I just don't know where I am. Because anytime you've got a map and you've got physical characteristics that you can read, you're never really lost. You are, in fact, you can't find your location on a given map. You can't find where you are. It's not like you're in a black hole where you've got no bearings at all.
Imagine you're a caveman living in, well, we'll say, this cave here. This is a cave. There's some rocks here and stuff like that. There's our cave. I'll draw a picture of you. Your name? Sorry about your legs. Your name is Grunt. You're talking to your buddy. Kronk. You can tell the difference between the two of you because Kronk's got dreadlocks. They hadn't invented combs yet. Okay, you say, hey Kronk, last week I got myself a beautiful mammoth and we've been eating mammoth steak ever since. Kronk says, hey, good deal. How do I go about getting some of that steak? Grunt says, I'll tell you what, I'll give you directions and you can draw yourself a map. Kronk says, good deal. I'll go get myself some birch to write on. I'll get some charcoal, and you can give me the directions. So Grunt says, well, let's say that we're at A right now. You're going to walk for 3 days. That'll bring you to B, which is that big old waterfall we always run into. Then you're going to walk for 7 more days. We'll call it C. And that's where the mammoth is. There's his tusk. Little hump on the forehead. There's his eye. Give him a bit of a trunk. Ugh! This is one ugly looking mammoth. There you go. Everybody recognized that as a mammoth. Now, what's wrong with this map? First of all, the chances of Kronk getting absolutely lost are almost 100%. For all we know, Grunt wanted Kronk to go from A to B, then C perhaps was down this way. Or perhaps he wanted to go from A back this way to B, then maybe up to C. We have no ideas. Grunt didn't give any specifications. So if we're going to draw a map, first of all, we need more detail. So what Kronk could have done is said, which way do I go? And then over here, where are we? Over here, maybe he's going to draw the sunrise. I'll just put down sunrise because you guys may not be able to figure it out. That's what that means. And if he decides that he wants him to go in this direction or straight down, he's going to say, keep the sunrise on your left shoulder, whatever. So we got some sense of direction. Also, it would pay to have some sort of direction as to what you're going to see along the way. So he might say, you're going to have to go through the pine forest. There's a pine forest. In order to get to C. There are other problems associated with this. Grunt may be able to walk at one pace in 3 days, but Kronk may walk at a different pace. The other thing is, Grunt is a hard worker. His day may be 12 hours long. Kronk's may only be 8 hours long. So how do you know how far he's gone in 3 days? If there happen to be other waterfalls along the way, there and there, that's a waterfall, you'd never be able to figure out what's what. So we've got to come to some determination of exactly how far you can walk in a day. Grunt has got to know his pace, and Kronk has got to know his pace.
This first exercise I'm going to go through, outline, is a method by which you can determine what your pace is. Then I'll ask you to do the same sort of thing at home. And after you've done that, well, come back and we'll start doing some work on compasses and figure out how you can figure out the direction you're going to go.
I've laid out a 25-meter tape. You could use a chain if you wish, even a meter stick repeated in order to lay out 25 meters. I'm inside to do this because it's raining outside and I'm lazy. Okay, what I'm going to do is I'm going to start walking from the beginning of the tape to the end where the orange flags are. I hope you can see them. And I'm going to count the number of paces I take as well as time that's the time it takes me to get from one end to the other. Okay, watch me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3. 33 steps. It took me 19.45 seconds and I covered 25 meters.
Okay, let's take the data from our little stroll down the hall and put it onto a data sheet. Here's the data table that we use for this particular exercise. Under the heading of site, I'm simply going to type in hallway, because that's where I was. Oops. Under distance, if you recall, the distance of tape, the length of tape I laid out was 25 meters. Notice I don't need to put in the units because I've written them up here. If I didn't have anything written up here, I'd have to put the units in here. We've got to assume everything we put in this box is going to be measured in meters. In the time, if you recall, I took the stopwatch up there and it registered 18.73 seconds. Again, seconds is up here. And I also counted out the number of paces. And as I recall, it was 32 paces. Okay, now, in order to calculate the length of one step, you have to take the total distance I went, 25 meters, and divide it by the number of steps I took, which was 32. Now, I can't do that in my head. So what I'm going to do is I'm going to take these same numbers in my handy-dandy calculator, divide 25 by 32. Lo and behold, I get 0.78125. I'm just going to call it 0.78 because much more accuracy is really irrelevant. I mean, we're already into the centimeters there. The next number would have been in millimeters. We're not that accurate. Okay, now, this is a good number to remember. The reason for it is because if you're ever out in the field and you don't have a tape and you need to measure something, for instance, perhaps there's a log on a beach. You decide you need to know how long that log is for whatever reason, maybe see if it'll fit in your truck, I don't know. You can pace it out. Suppose, we'll choose a nice simple number, suppose that log was 10 paces long. That would be 10 times 0.78 meters, which is 7.8 meters. I don't know if that would fit in your truck or not, but there you go. If you always remember this number, or get a good sense of that number, you can measure all sorts of things approximately. The length of a dock, the length of a trail beside a creek. Okay, so we can use D in the next step here. There are 1,000 meters in a kilometer. Therefore, if you want to determine the number of steps it would take to hike a kilometer, all we have to do is take the 1,000 meters and divide it by the length of one step, which is up here, D. So I'll tell you what, I'll get my handy-dandy calculator on, even though I know every one of you could do this in your head. Put down 1,000 meters, 1,000, divided by 0.78. I'm going to get 1282.05. Okay, I'm going to put that down. Oops, put that down. Why is that happening? Put that down in here. 1282.05. And that's going to be in meters. And we'll use that E later. Now, let's go to the next page because we've got more stuff to do. Just minimize that. To determine how long it takes to walk 1 meter, you need to divide the total number of seconds it takes to walk 25 meters, which is B, by the distance covered, A. Okay, remember right in the beginning, I'll bring back the calculator here, right at the beginning in that box we had on the first page, under B, we had the time it took, and if you recall, that was 18.73 seconds. And we're going to divide that by the distance we covered, A, which was 25 meters. So I'll make sure I hit the divide 25 meters, and we get 0.7492. Okay, so I'm going to just put in here 0.75. I think we'll round it up. Oops. That's how many seconds it takes to walk just one step, if I remember correctly. 1 meter, sorry. Now, that's the number of seconds it takes to walk 1 meter. What if we want to know how many seconds it takes to walk a kilometer? All we have to do is take this number, which is f, multiply it by 1,000. And, well, let's do it. We'll do it the honest way. We'll get a calculator, even though I know you could do it all in your head. 0.75 times 1, 2, 3 zeros equals 750. I know you all guessed at that one. That's how long it takes in seconds to walk 1 kilometer. Now that information is not particularly useful, because who's going to time that sort of thing? What we want to do is we want to convert these numbers into kilometers per hour, because that's a number we can use. Okay? Now, this explains where we get the numbers from. There are 60 seconds in a minute, 60 minutes in an hour, so that's 60 times 60, 3,600 seconds in an hour. We want to find out how many of these will fit into an hour. So we take G and divide it into 3,600 seconds. Handy dandy calculator again. And we've got 3,600 divided by G, 750, equals 4.8. I walk at 4.8 kilometers per hour. Pretty pedestrian, pretty slow. I'm sure a lot of you can hike a lot faster than that. Okay, with this number, we're in a position where we can work on a map and guess or calculate how many hours it will take to get from one place to another, because we now know how fast we walk. And if we know the distance between two places, we can figure out how many hours it's going to take to get there. Okay, I'll leave you with this, and after you've done your exercise, I'll see you at the next lesson. Bye-bye.